This week, my wife decided to visit her parents, and she also decided to take the kids with her. But before any feelings of delirium could sink in, there is always something need doing while she's away. Luckily for me, the list was not long this time, but could have been better illustrated. And this involved cutting the grass, jet washing the deck, digging out the flower bed, and most important of all, something I must not forget, water her prized flower baskets. Well, I filed all this away as non urgent, as this was a perfect opportunity to get on with a project that I have been wanting to do since buying my Prusa i3 Mark II, and that's to at last install OctoPrint with added camera feature.
Coming real, it's the next episode.
So I powered up my laptop, whipped out my CAD tool of choice, put on some background noise to put my mind into design mode, and slowly eased into it. This is our basic setup to set up Octopi, and of course the star of the show is the Raspberry Pi 2 Model B. It's cheaper than the Pi 3 and readily available. Besides, I have a few lying around. As we're using that, we'll need a Wi-Fi dongle, a micro SD card, 8GB is sufficient plus its adapter. The Pi camera does come with a very small ribbon, so I scrapped that and ordered a longer length. I opted for 1 meter, but I feel 1.25 meters will be sufficient as it gives you more options for routing this under the Prusa. Some additional components I got was a NeoPixel 16 LED ring based on the WS2812B addressable 5V RGB LEDs. This ring should run no more than 1 amp when all the LEDs are white. A 1000 nanofarad capacitor running at 6.3 volts. I'm using a 10 volt as that's what I have at hand. In addition, a 470 ohm resistor, and these both will prolong the life of the NeoPixel. You'll also need a power supply in the form of a mini USB input. I also purchased some heat sinks and a 30mm 5V fan as I hope to overclock this Pi to its max. And even without these cooling options, it will still run stable and should not damage the Pi, but the unit will be encased in an enclosure. So for not much cost, it's well worth taking that precaution. Right, let's get on with uploading the software. Installing OctoPrint can be so easily done in 5 simple steps, and is really not that scary of a procedure once you understand the process. I'll provide instructions for both OS X and Win users as I'm a user of both. The first thing to do is format your SD card using SD formatter, which is the same for OS X and Windows. Download the image file from OctoPrint download page and burn the image file onto the SD card. Of course, this is the same for Windows users. For OS X users, I would recommend using Apple Pi Baker, and for Win users, use Etcher, which is also compatible with OS X. Once the image has been burnt, from the root of the SD card, open up octopi-network.txt file and go to line 2829 and remove the hashtags, and input your Wi-Fi details and passwords and save. For OS X users, I would recommend Text Wrangler, and for Win users, of course, Notepad++. Now it's time to put the SD card into the Pi and power up for the first time. Once the Wi-Fi dongle has stopped flashing, jump onto any browser that is networked to the same Wi-Fi network as the Pi and type in http://octopi.local. If this doesn't work, like it did for me, then you can also put in the IP address that is assigned to the Pi. This can be found on startup of the Pi if you plug this into any HDMI display. The same for Win users again. Congratulations! This will now start up Octopi user interface and you're ready to roll. Just follow the on-screen wizard and set up the parameters of your printer and just play with it to understand how it works. And now that we know the hardware works, we can crack on with designing the parts required to fit these components to the Prusa. The first place I wanted to start the design from was how am I going to fix this camera to the Prusa. and how do I want the camera to move. Basically, I want the camera to move with the bed, so that when I take a time-lapse video, the video is showing the layer being built progressively as opposed to just a blurred image of the model going backwards and forwards. And there's plenty of examples on Thingiverse where there is designs available where you can clip it in just underneath the bed where the bed support arm is. So there's no point redesigning the wheel. My bed mount, the camera mount, will be loosely based on other designs available on Thingiverse, which do work quite well. But obviously this will be heavily modified for my own needs. So once I've established the method of mounting the camera to the bed, the next design brief I gave myself was to make the camera adjustable, both in the vertical rotation so it can pan from left to right, as well as horizontal panning up and down. I've also got some GoPro fittings that I wanted to utilize, especially the thumb screws, as I've got many spare parts there. And so this design had to also implement that, and this particular fitting was to create the vertical rotation from left to right. The camera itself has a ribbon. The ribbon then comes out of the PiCam and into the Raspberry Pi, and it's about 60 millimeters in width and it's fairly flat. So the clip there at the bottom is really to guide the ribbon down behind the camera so that it's tucked away and safe. So now we're moving on to more interesting part of this project, which is to design the actual case for the PiCam. What I like to do always is to start off with a reference sketch. So what I'm sketching right now is the actual important parts of the PiCam. So we've got the mounting holes, the lens in the middle, and then the overall size of the circuit board. And this sketch is just a reference sketch, so I never extrude from this. I just have it in the background so that the next few sketches I can design from. So we're creating the main case here. I tend to shell it out so that I got easy access to dimensions if I want to change the thickness. And I've decided I'm going to create mounting sort of pins, and then the secondary pins will go into the mounting holes of the PiCam so that there's got some location. The next thing to think about is the actual slot for the ribbon that connects to the PiCam. I've decided to make it 2mm clearance either side, as well as a 2mm slot. But instead of creating a slot, I've decided I want to avoid bridges, because again we're doing FDM. I've decided to just extrude it so that it's just a cutaway. This mount for the PiCam is going to come as two parts. So you've got the base itself, which holds the PiCam, and then you'll have a lid that will clip over. And there's 3 clips, top and either side, which will leave then a slot at the bottom. The lid itself also needs to incorporate a NeoPixel ring, which I want to illuminate the time-lapse videos with. It's important to kind of, again, design with the process of FDM, because we can't obviously have too many overhangs. We can have some, but we can't have too large overhangs. So here you can see I've decided to keep the base as flat as possible so there's maximum contact with the print bed. But also now I'm looking at designing in the NeoPixel mount as part of this lid. You know, you have a general idea, but you don't have a full understanding of what you want to go. So I just tend to draw something out quickly, and then from there I can always modify it and tweak it until I'm happy with the design. So this is my idea, is that we're just going to have 4 arms sticking out and some sort of location slots for the rings itself that we can just clip into. Later on you'll find that the design doesn't work at all, and we decide to then just completely tweak it afterwards. And also you have to bear in mind I don't have the NeoPixel here, so I'm having to kind of work out what the size is going to be. And finally, once we've got some of the basic components, I can start producing an assembly. And this assembly will then allow me to understand where there's interferences, how I can make the minor tweaks and adjust the design fully so that we can then appreciate what we've got as final components. And this part is actually where you realize all the mistakes you're making once you've assembled them all, and where all the interferences are happening. But it's really a really good part of the design is to assemble everything on CAD, even before you decide to 3D print anything. And a lot of the mistakes and oversightness that you have can actually be remedied at the assembly stage. So there was quite a bit of CAD work I'd done, a couple of days at least, and I don't want to bore you with too much of the screen grabs I've got here. But once I got to a place where I was quite happy with the design and thought, okay, this pretty much everything that I've got that is not going to interfere is going to work, it was time to get on with slicing these models and 3D printing them. So let's move on to that. So using my CAD software, I can then start orientating how I want to produce the STL files, and then bringing this into Slicer Prusa Edition. I then began to set up the G-code to send to the 3D printer manually via SD card. And from here, I realized that there was again more tweaking I needed to do via the printed models. I went back to CAD and redid those changes. Finally, after about 5 days worth of work from start to finish, I was quite happy with the final result. It's now just a case of assembling the parts and setting this up on the printer. Okay, I'm going to go through what parts we need and what parts have I slightly modified so that it best fits with within the OctoPrint. Now these minor modifications are entirely up to you. They will still fit, but I just wanted to keep it all nice and tidy. There's some extra bits that you'll need: double-sided tape, VHB if you have it, but it's not necessary. You can use hot glue. I have got some GoPro screws, but again, you can just use standard M5 hex nut and 3D print yourself a knob. And also these parts are available on Thingiverse. I've also got this LM2596. It's basically a step-down DC to DC converter. Again, this is optional. This is for me to power up the Raspberry Pi when I switch on the Prusa, and I've soldered some tails on their input and output. And I'm going to be powering up the NeoPixel ring through this as well. But as I said, this is totally optional. You can power up the Raspberry Pi via an external micro USB. The enclosure will provide for that. But I'm just trying to make it nice and tidy. So I won't cover the installation of this, and including how I soldered the tails and why I've done it the way I've done it. But if you want me to cover that, I can always add that as an extra episode later on. Obviously, the Raspberry Pi itself, and the only additional thing I've done there is to put the power on using the solder points at the rear of the Raspberry Pi. And again, this is so I can power it directly from Prusa's power supply unit using the LM2596. Finally, again, this is purely optional, so it has a power in and one single signal wire. On the other side, I've soldered in a capacitor, and within this shield, 470 ohm resistor. I'm not 100% sure how I'm going to get this to work through the Raspberry Pi, so I've created this and wired this up, and we'll fit this to pin, I think, 8 on the Raspberry Pi. And I'm hoping whenever the printer starts printing, I'll hopefully run the M150 code, and that should hopefully get this up and running. If it doesn't, I will probably need some input from you guys if you know how to do that. Right, let's begin with the fan. Very straightforward. Pop in the 4 screws. Right, the Raspberry Pi next. Straightforward. There we go. Everything lines up as it should. Not that we'll need any of this because we're going to power it separately, and the Wi-Fi dongle fits in there. So nice and comfortable fit there. I'm going to choose to install my LM2596 here, just beside the fan. The camera ribbon I've already connected, so now we can assemble the camera into its case. I've pre-superglued the mounting at the back of this camera mount. These comes as 2 separate parts. The first thing you want to do is feed in the ribbon into this slot here and just basically plug it in. Finally, the lid itself will just pop over and should just clip in. Nice, satisfying clicks as they go in. Now the ring will sit here, so the wires are going up and over, and so this is designed so that it lines up with the outer edge and sits fairly central like that. But I'm not going to install the ring just yet. I'm going to first of all work out the wiring for that, and that will be the last thing I do. Next is the actual camera mount stand. Two parts. They simply click in like so. This bit, when you put this into its stem and tighten it up, so that will then basically clamp around the neck of the second part, and it should be able to rotate freely and obviously retain it, so it acts as a dual purpose component. And finally, you can then pre-assemble these two sub-assemblies. And there we go, we've got a fully articulating camera. And all we need to do now is just tidy up the ribbon. The ribbon is straightforward. You've got the first hook here, and then you've got the hook underneath, and then that will just go through routing underneath the Prusa via these assortment of clips, and this one here as well. Okay, let's install this on the Prusa now. Installing the parts on the Prusa couldn't be any easier. First of all, let's power off the Prusa so we know we're safe. Move the bed out of the way. The first component you're going to put in there is this part here, which is a harness guide that clips very easily onto this rail, and I would say about a couple of inches away from the front. It's not crucial. The second thing you do is install your camera. That goes underneath one of the bed arms, and then you basically feed this ribbon, making sure it doesn't get twisted, into the harness guide and out the other end. And pull this through slowly, and there we go. Can we see that? So it goes through underneath there and under there. Now we have two more clips here. So that clips in with the longer piece facing the bed. Same on the other side as well. You want to obviously make sure that they're lined up. So you can see the two clips here and here. Now here comes the tricky bit. So I have this second guide, and how this works is it engages with the frame of the Prusa and sits right in this point here. And then this keeps the ribbon from being rubbed up against the frame and the wires being exposed and damaged. So it's very easy. All you do is you loop, making sure it's not tangled again. And the longer end is towards the bed. Feeds in like so. There's two slots on here, top and bottom. Feed that through. Now this is quite difficult to film. Lift the bed up, lift the printer up. Basically sit this down on the clip itself. You're probably worried that it's hitting the ribbon, but it won't hit the ribbon because if you pull it, it's actually free to move like so. And then what you're left with is the ribbons on the other side. Here it is coming out from the guide underneath the frame and keeping it low down. The ribbon needs to be fed in this orientation. It needs to stay like this. It can't twist around like that. It needs to stay like this so that when you come to the end, the blue tab should be facing up and the connectors should be facing down. So without again twisting the wire, feed these through two of the clips that we put in earlier. Turn that clip round so it's facing the other way. Feed it through. Loop it underneath. Just make sure you don't damage that ribbon, and then twist that clip round so it's facing directly down. Now you'll get this funny shaped loop here. It should be fine as long as you don't tug at this too hard. So the ribbon will go all the way through here, right underneath all the wiring, and lay it flat across the control box for the Prusa. Now I've got this additional cable I've wired directly into the power supply unit. This provides me with 12 volts for my DC to DC 5 volt buck converter step down, and I'm going to go around the control box and into my enclosure like so. Like so. So mine is all connected up nicely. Right, so that's all connected. The next thing is to start fitting the enclosure in place. That clips into the frame. let's connect up our fan. I don't know what pin number's there, but there's a 5 volt and a ground there, so you just connect it up to your GPIO, connect up the Raspberry Pi to your power supply. Okay, so this bit is going to be extremely fiddly, so you've got to kind of feed the ribbon in. So I want to point out the blue part of the ribbon faces the LAN network and the connectors faces the HDMI. So make sure the orientation is correct and it's firmly fitted in. Then you can close up the case. So the last thing to do is to screw in the case into this hole in the frame. There you go, you're pretty much done. So again, I just want to point out here, clearly see, here's a ribbon, it's now sticking out. If I push this back, it will clearly hit the bed and could rupture this. So yeah, with a longer ribbon, I would even recommend coming around the other side just to completely keep this area free from interference. So order of 1.25 meters, what I'm going to say. That's probably the best thing, and go around the other way. So the ribbon cable is nicely tacked in there. Got my own power supply coming off the Prusa power supply unit, and the whole thing is now fully integrated. Camera, as you can see here, with the NeoPixel ring, and we're done. So let's switch this on and see what happens. Okay, I'll plug this in. The Raspberry Pi should start powering up, and then the camera has a red LED light and it should illuminate. I can see the fan has come on. Okay. There we go. Wi-Fi dongle is flickering and the camera has come on. So success. Everything's been wired up correctly. We can now put that into this correct orientation. It's fully adjustable. Went downwards. There we go. That was definitely fun exercise, and I think the next thing is to try to get the NeoPixel for me to work, and we should log in and see if we can get access to OctoPi. Okay, so I got Safari open. I know you haters, you all love Safari. So I will put in my IP address and then we'll wait to see if it's going to load up OctoPi. Okay, that's a good sign. So it's found OctoPrint, and now I just need to press connect. The webcam definitely works, the Octocam works. Those are the time-lapse settings, that's the terminal. So let's just connect physically to the printer. I always look at the terminal to see what's going on. That's the first indication of something's going to happen or not. Okay, I think we're in. Yep, it's starting to read temperature, so it's definitely in. I'm actually going to take this opportunity to upload a modification to one of the harness guides. I want to incorporate a screw so that the harness guide doesn't move about. So let's reprint that part and also try to record a time lapse, see how well that works. So I've uploaded the model and there's the view from the camera, and let's just see if we can select print. You can select it from the actual file, or you can just select it from the big button which says print. There we go, the printer is starting to find its homing positions. And if I go to the terminal, there's the G codes as it writes to it. And now it's just doing bed leveling. Just keep a note of the ribbon and watch how the harness guide keeps the ribbon out of the way as it bends over and folds on itself as the bed moves. We'll just wait for the temperature to rise up to what is set as 215. So that's what we set in the G code, and when it reaches that target temperature, it should hopefully start printing. So we're getting very close to this target temperature. The G code viewer shows you each of the layers that's going to print, the perimeter as well as the infill. This is sometimes works for me, sometimes it doesn't. There we go, it's starting to print. I think this was really another point in case of my love for design and development. Again, with the Prusa aiding in this process through rapid prototyping to enable testing of the conceptual design physically so that the tweaks can be made to make this as ready as it can be as a fully working design. And looking at some of the previous versions, you can see very nicely how the design has evolved to a more improved version. Nonetheless, as an engineer, you're never fully satisfied with what is finished and you are your own worst critic, which I think is a good thing. I will, of course, in the nature of our global maker community that exists, offer these for free on Thingiverse. But if you're able to send me a tip, it would help the channel, but of course it's not compulsory, and I hope you have great fun assembling your own Octopi setup. Let me know your thoughts in the comment section if you want me to cover more on the OctoPrint user interface and its growing plugin page and explain the must-have plugins for you to install. Having now used Octopi for a few days, how do I feel? Well, how can I explain this? I would say this is more akin to when you're asked, what was life like before we had mobile phones? Or what did we ever do before Google? Yes, even remember the time when we used to communicate with bits of paper and pay someone to deliver that paper across the globe and then wait weeks for a reply? Yes, it is really like that, and I wish I had done this much sooner. So go out and buy a Raspberry Pi and say goodbye to failed prints and asking why by simply installing OctoPi. Now, I know what you're thinking, it's all very good procrastinating, but what about the chores? My clear explanation of how the polar jet stream, which are rapidly moving ribbons of air 6 to 9 miles above this side of our planet, influences the unpredictable UK weather by separating warm and cold air pushing weather systems around the globe. The position of this jet stream above the UK affects temperature and precipitation, and thus can bring about sudden and unexpected downpours. Yes, it rained. Hopefully, if I can baffle her with the science, it may all be forgiven, but somehow she always finds out.